All right, with this one solution, I can use it to find the others, just like earlier, very early in this video. When I found one factor, I could divide it in to get the other factors. So I'm going to take 1 and divide it into 1, negative 13, 47, negative 35. I know that I'm going to get a remainder of 0 because this 1, which would represent x minus 1 as a factor, is indeed a factor. Bring down the 1. 1 times 1 is 1. That gives me negative 12. Negative 12 times 1 is negative 12. Combine for 35. 35 times 1 is 35, which gives me, as I anticipated, a remainder of 0. Now these numbers represent the coefficients of the other factor, and they also represent the coefficients of what is known as the depressed polynomial. It is depressed by 1 degree. The original was x to the third. This will represent 1x squared minus 12x plus the constant 35. So when you started with x to the third and you found a 0, a factor, the numbers here represent the coefficients of the depressed polynomial, which is the other factor. Now I take it and I solve it. I need to solve x squared minus 12x plus 35 equals 0. Now you have a choice. You can factor it. That things are messing up. You can factor. You can use the quadratic formula. You can complete the square. This is really messy, I'm sorry. Or sometimes you can use the square root property. You use the technique you want to that will work. This one happens to be factorable. So I have x minus 5 and 7. If that's a factor, then x is equal to 5. If that's a factor, x is equal to 7. This was a third degree cubic equation, a third degree cubic function. It has 3 factors, it has 3 roots, it has 3 zeros. They are the given 1 and then the 5 and the 7 that I got from the depressed polynomial. You have those 3 answers. You had x equals 1 to start with, and then you got 5 and 7. If you wanted to write it as factors, this one would be x minus 1, this one would be x minus 5, and this one would be x minus 7. This problem didn't ask us to do that, but I wanted to mention it. The last problem, very similar, but we are given a third degree polynomial equation and a third degree polynomial in function form, and we're told that negative 1/2 is a 0, a solution, a root. So I will use negative 1/2 and divide it synthetically into 4, negative 1, negative 1 to get the depressed polynomial, and I'll solve it. Bring down the 4. 4 times negative 1/2, positive times negative is negative. Half of 4 is 2. Add for 2. Positive times negative is negative. Half of 2 is 1. Negative 1 and negative 1 is negative 2. Negative times negative is positive. Half of 2 is 1. That gives me a remainder, no surprise, of 0. Because when something is a 0, that means that it represents a factor. You will get a 0 remainder. So now I need to solve 4x squared, it's depressed 1 degree, plus 2x minus 2 equals 0. You can use factoring, the quadratic formula, completing the square. This turns out to be factorable, so I'm going to factor out the common factor of 2. That leaves me with 2x squared plus x minus 1 equals 0. So that's, I can factor that. I'm going to have 1 plus and 1 minus. I will look at a 2x and an implied 1x, and 1 and 1, and I believe I probably have to reverse my signs. I do. Put the minus there and the plus there. The outer product is 2x, the inner product is negative 1x, and that will give me the correct middle term. So 2x minus 1 equals 0. 2x is 1. X is 1/2. If x plus 1 is 0, x is negative 1. My solutions are the given negative 1/2. Then I was able to get positive 1/2 and negative 1 from the depressed polynomial. Those are my 3 solutions. These were all rational, and you could have gotten them from the grapher. But in a future lesson, they will not always be rational. We will not be able to factor this. We'll have to use probably the quadratic formula, and we will have conjugate pairs. So that's something to think about.